Hello, my name is Brian Frater, and over the next few days I'm going to construct a solar heat collector. This is being built as a project for HLSS 232, Electronics, Electricities, and Explosives. This solar heat collector is going to be used as a test device for a larger scale heating element. This video will catalog the steps I took in building this device. You may ask yourself why this is important. Now, I will tell you there's some pretty ingenious ways that you can use this heat collector. Number one, it really doesn't take anything to power it other than the sun. On a nice clear day you can generate, mine generated about 130 degree heat. I think it could generate more if I would have ventilated a little bit more, and the next one I build probably will be ventilated a little bit better. But I just wanted to do it simply and see how this worked. January 17th, me and my son working through a bunch of recycled cans we got from a local bar. This is what we're going to be building our heater out of. Alright, we wound up with 350 cans, and we'll see once we get done building this, kind of building it as we go. So we'll go over the power requirements here in a minute. I'm back again. I'm preparing these cans. Some people drill the cans the whole size of the can. Some people don't drill at all. Some people drill a lot of holes in them. I'm just going with one 1-inch hole right in the center of the can. I'm using a drill press and some protective gloves, so if the can disintegrates, these are anti-cut-through gloves. My son and I are working on this. We're trying to use as much recycled goods as possible. This is a door that we had on the front of the house. It's been sitting in the garage for a little while. The frame is broken on it. Wind had got it, but the glass is still good. So we're actually going to make our collector the same width as the glass on the front of this to save money on purchasing it, because that can cost you quite a bit. We're using the 2x4s for the sides. You can see I've started to construct the base to it. We went to the hardware store, and our local Do It Best helped us out, and they gave us this green piece there. They were using it for a sign, but had gotten rid of the sign, so it actually is the same size as width as our door. That's how I selected it. So you see we got 3 8-foot 2x4s. It may take one more if you're going a complete 4-foot wide. We aren't doing a 4-foot wide. So we got a saw, got that, got some heater vent, and some glue to stick our cans together. You saw our cans earlier from when we were collecting those. And we'll get back with you when we get a little bit further into the project. Alright, what we've done here is we've created a box. You'll see we got the header where the cans are going to sit on top of. We will go ahead and we're going to probably drill a hole right in the center here, about 3 or 4 inches in diameter to get the air forced in, and then we'll also put a hole at the top. The next thing we have to do is flip it over and attach the actual bottom of this to the actual frame itself. Alright, you see we're starting a process of putting the cans into the holes. Just set them in the holes. I'm going to be gluing them using some good old-fashioned liquid nails. Just a little bit of glue around the bottom of each other, probably a little bit more along these so I get them set in place right. And that's our base, and of course then we'll build them all the way up to almost the top. We'll probably stop short of the hole up there so we can get the heat to go through that hole. Alright, this is my daughter Gwen. She's helping us out. This is not scientific. It's easy enough that a 3rd grader can do it. Literally, we just put a bunch of the glue right on a piece of trash, dot the bottom of the can, and start stacking them. We're trying to keep the air in the best we can, but this thing's not going to be airtight. You're using aluminum cans that have been recycled and whatnot, so you just do the best you can. We stick them together so if this wind blows it around, it doesn't completely come apart. And we're trying to use the same type of can. I mean, in the end, we may have to go to a different type, but we're trying to use these first. Try to use them in chunks so they all fit the same. Okay, now you'll see we've completed this. I mean, literally it took us probably 20 minutes when we started gluing and sticking. You'll see on the far right side we got a set of cans that really don't go anywhere. Those are just to space them in and keep it tight left to right. It wasn't perfectly made. But we didn't want it to be, we weren't using anything crazy. We got all Keystone Light cans in there. You'll see we got a gap at the top. This is for the air to push in and out that hole. Okay, and now we're going to put some foam around the outside of the thing there. You're going to see here in a second. And we'll put the glass on. Okay, so what we're doing now is we're spray painting. Now, I'm not putting a lot into this, to tell you the truth. I'm making sure that they're all coated pretty well. I didn't spray them before I put them in because I didn't want to waste the spray paint on the back of the cans. The black on the back of the cans I don't think would affect it too much. It's a windy day, and the spray paint, I'm using the high temperature spray paint. And we've got most of them black, and we're going to finish blacking out what we know, you know, what else we can hit. We're going to make sure the inside of the whole box is black so it collects the heat. But you know, really, there's a lot of different things you see on YouTube that you can do. You can put insulation on the inside, but you know, I was really going for the financially frugal person that doesn't want to spend $100 in pieces and parts and all the little stuff that in the end really kind of costs you money. So I really have money just in the 2x4s around the outside, the spray paint, and the glue, and it's about 30 bucks all together with everything. It was kind of high. The place I kind of bought this stuff was a little bit high, but it was close. I didn't have to drive really very far. So I'll be back with you in just a minute. So this is our complete product. My window was, I was good on the width. I just assumed it was 8 feet tall, and I'm an idiot. No doors, an 8 feet tall door. So I was a little bit long. I used the old Manorific duct tape to finish off the bottom up to close in the bottom header. I mean, like I said, this is doing pretty well. It's completely ran off that 45 watt solar panel. You can see I got my cables running over. We tried a smaller air pump earlier, but this gave a lot of air in a small area, but just not enough oomph to get the air really out the top fast enough. So we took a DC fan. It is a 5 watt DC fan, and as you can see, this is a highly coveted duct tape to cardboard to duct tape to a dryer vent into the bottom of it. We would use this as a cold air return. Now what we will do is I'll probably get a longer one of these dryer vents and run it to the top of my garage, where I will then use the same fan to pump that air out of the top of my garage down to the bottom of this, outside of the garage to the bottom of it. And you'll see on top we have the hole up there, and that's where our temperature's running out. Now we literally just started this up, so let's go back up top and see what it looks like.
Today's March.
Yep, today's the 19th of January. Now it's an unseasonably warm day. It's 58 degrees here. We're all in short sleeves, and you can see my mess from where I was making this beer can thing. I drilled out about 150 cans more than I needed to. But right now we've had this thing running. We just got it done. Now we started building this at 9 this morning. It's now about 1:30 in the afternoon, and you'll see that it's running at nearing 140 degrees. It's been running for 10 minutes. Now I'll show you what I got running with it. That's inside the case. I built this only for an experiment to see if I could get the internal temperature up with the air moving through it. So you'll see this is left or right. I got it at about, 45 degree or so angle. Completely non-scientific. Sunny day. The check I did where it was near 140, that was literally less than 5 minutes ago. We're now at 160 degrees. We're midday, so we'll be collecting this for a while. I could easily pipe this into my house and heat. Okay, so what I did there is I put a vent out the back of it, because the question is inside of the case, yes, it's 160 degrees. How hot is the air moving through the tube? Well, I'm going to tell you, you put your hand on it, it's pretty dang on warm. I got a little bit of air blowing through there, and this would probably heat a decently sized area. If it was really cold outside, it would make a big difference, and it's not that cold right now. We're cruising over 120 degrees. It's still beginning to heat up. Now this is the air that's passing through the cold air intake, which I have down bottom here. You see the fan? See the hose into the bottom of it? This is about as simple as it gets, right up to here. Now my power source, of course, is 100% solar, and it cost me the price of the panel, but I could have probably put it all together for about $70 for this panel and everything I needed, but I went a little bit higher so I could have a better capability later on to use. I didn't want to go halfway, so I essentially tripled my capability with less than half the cost, less than double the cost. But you see right now, since they're still cruising over 120, it's getting up there. Okay, you can see we're running steady at 130 degree heat coming out of here. I could increase. Of course, I have this thing neck down. I could put a bigger hole in it. I'm a little bit restricted right now on my airflow. I just want to see if it works before I do anything else to this thing. So I think we're meeting success. I can't even really show you with this, but it's not really even sunny out. We have a cloud cover right now, and it's holding pretty steady. So let me get you right on here. Yep. Hey, this is what we got. We have three 15-watt solar panels that right now we're collecting. It's about 4 o'clock in the afternoon. You know, sun's kind of on the downside, so power generation is not at peak anymore, but it's still doing pretty good. It then has 3 cables that run up here. They go into one cable. This then goes into and feeds into my power regulator. Now what this regulator does is it steadies the battery fill. So, you know, during the middle of the day, the battery it's charging, it's putting way too much power into that battery. So this kind of necks it down during the day, and then during the afternoon, it allows it to charge fully. So the battery I'm talking about is right here. I'm charging this little motorcycle battery just to see how this does. Let's see how this system runs. Okay. At the time right now, we are making 14.7 volts. Of course, we know that's only power potential, or potential power. That's not watts or amps. Okay. Then I also have the DC out. Well, this is going out. This then goes down to and over to our heat collector. See the fans running down there. Now it's not running really fast because I've plugged in the battery at the same time. It's a lot to charge at the same time. And you can see right now we're running just over 100, about 110 degrees, which isn't doing too bad late in the afternoon like this and on a January day. So I hope you've liked this electrical system. Thank you for watching the video. I hope it was descriptive enough. Many of my resources, to tell you the truth, was YouTube, and I will have a list of those that will be posted with this video to make sure that those that have already done this ahead of me get credit for what they've done. I made sure that I did this different than I had seen. I cut smaller holes in the bottom of the cans, and I didn't cut holes on the top of the cans. I used a little bit different of a propulsion system. I appreciate those and the many different ways that people do these, and I will probably vary how I construct this thing. If you see, I still have a lot of cans left over, and I actually plan on building a much larger size of these. To me, this is a success. At the peak of heat, it's putting out 130 to 140 degree heat. I think if I was to raise the ventilation and widen the array, I would be able to raise that heat. So thank you for watching this, and have a nice day.